Today we will be talking about linear versus nonlinear functions. Okay, linear means line. Okay, it is a straight line. It can be a diagonal straight line, it can be a horizontal straight line, it can be a vertical straight line. Okay, it just needs to go at a constant rate, whatever that rate is. Okay, now when we look at a graph, see how it has a bend in it? That is non-linear. Straight line means linear. Okay, straight line, linear, bend, non-linear. Okay, you try those two on your own. All right, now we have situations. The height of a rock is falling off a cliff is a function of the time after the rock starts falling. The rock accelerates as it falls. Does this situation represent a linear or non-linear function? So if it accelerates as it falls, that means it's getting faster as it gets closer to the ground. That would indicate that it would have a curve in the graph, which means non-linear. Remember, the same rate of change or constant rate of change means linear. Okay, so this one here, a worm eats 2 grams of dirt every day. Well, 2 grams every single day, that's the same every day. So the total mass of the dirt over time that the worm eats is a function of the number of days. Does this represent a linear or non-linear function? And they gave you a graph of it. You can see that graph is straight line, so it is linear. And again, 2 grams per day, that is a constant rate of change, which means linear. Okay. Now, if we look at some tables, when we're looking at tables, we need to make sure the rate of change or our change in y over the change in x is the same throughout. So 0.5, 0.5, 0.5, 1, 1, 1, which means your slope remains the same throughout. So this is linear. Okay, this one is 30 over 1. This is 120 over 1. See how these are different rates of change? That means non-linear. I don't even have to try the last one, okay, because they are non-linear. Do one more. 9 to 18 is 9 over 1. 18 to 27, 9 over 1. 27 to 36, 9 over 1. So this is linear, okay? And I'll let you try those 3 on your own. Okay, when we are looking at equations, if it can be written in the form y equals mx plus b or in slope-intercept form, then it is a linear function. So if we look at 15, y equals 3x plus 7.5. This is in slope-intercept form, so this is linear. 17, x divided by 4 equals y plus 5. Well, if I subtract 5 from both sides, I would get x over 4 minus 5 equals y. So this is y equals mx plus b. 1x, this would be the same thing as 1/4. You could rewrite this as y equals 1/4 x minus 5, or 1/4 x minus 5 equals y, either way. X divided by y. If I multiply by y on both sides, I would get x equals 8y, then divide by 8 on both sides, and I would get x divided by 8 equals y, which would be 1/8 x, or y equals 1/8 x. And this is in slope-intercept form, so this would be linear. Okay, so all 3 of those would be linear. Now this one here, y equals 3 divided by x, when a number is being divided by x, we cannot write this in y equals mx plus b format because it's being divided by x. So this is actually non-linear, okay? When we have an exponent, okay, exponent is going to look, it's an exponential function. It's going to have a curve in it because each time it's going to get steeper and steeper. So any exponent indicates that it is non-linear. Okay, same with our square roots. Okay, when we see a square root, we would have to square both sides in order to undo that. So we would end up with y equals 2x squared minus 100. Okay, because negative 10 squared, or sorry, 10 squared is 100, so minus 100. And this exponent would make it non-linear. Okay, so those three are examples of non-linear functions. So if it has an exponent, it's non-linear. If it's being divided by x, it is non-linear as well.